When an ASP.NET application needs to talk to an external service or an API, it needs to make an HTTP request. This is easily done using an HttpClient class, which acts as a session for the HTTP request. An HttpClient instance is a collection of settings applied to all requests executed by that instance. HttpClient can be used easily, but in some cases, this is being used incorrectly. In this video, let's look at some common mistakes made when using an HTTP client and what issues they cause. We will then see how to improve the usage of HTTP client. Hello everyone, my name is Rahul and welcome back to my YouTube channel. If you are new here, please hit the subscribe button below and help me grow this channel. Without much delay, let's head out to the console and use the .NET CLI to create a new ASP.NET Web API application. So using the .NET new and specifying the web API, this is creating a new template in the current folder. Let's open this up in an IDE. I will use Rider for this example. However, you can use any IDE that you usually work with. I have the application opened up in the IDE, and here we have the program.cs, the startup.cs, and the controller by default. We have a weather forecast controller, which is now being hard-coded to return some random values. To make use of an HTTP client, we need to get data from an external API service. In this case, let's use a weather API to get data of the weather. For this example, I will use the API provided by this site, Weather API. I have chosen this for no particular reason other than it has a free pricing tier which allows me to do this demo. Let's head off to the API Explorer to try out this API. Here, this needs an API key. I have already created this, so let me copy paste that in here. Let's leave the protocol as HTTP and the format as JSON. So if I was to pass the value of a city as part of queue and make a request for the current temperature, I can see that in the response here. So let's make this exact request and get back the results in our application as well. So I'll copy this URL because this is what we want to make the request against. Note here, the key is getting embedded. To try this, you will have to make your own API key. So let's copy that and go to the weather forecast controller to clean up the code to make a call to this API. Since we no longer need these hard-coded values, first let's remove them. We also don't need any of this code, so let's get rid of that. And in this case, I'll return back simply a string and then expose a function to get by city name. So let's say task of string and also pass in a city name as the parameter. So let's give in city name as the value. We have the URL already copied in, so let's use that to make the request. In this case, I don't want London, but I need to pass the city name that comes as part of the controller request. So let's make this a string interpolation using the $sign and change this London to be the city name. For now, I will leave the API key hard-coded in here. Normally, you would extract this out into a config file and use it from there. If you're new to configuration in ASP.NET Core, check out the video linked here which explains it in detail. To make a request to this URL, we need an instance of an HTTP client. So let's make one. So where HTTP client is equal to new HTTP client. This has created a new instance of the HTTP client. We can now make a request to this URL using the HTTP client.getAsync call and then pass on the URL. This is going to make a GET request to this particular URL. So let's get back the response using where response is equal to and add an await since this is an async call. Since we added the await, let's also make sure to add an async to this method. To get the content as a string from this response, let's use the response.content and then specify read as string async method. So this is going to read the content as a string. So let's await this call and return the whole value in this particular API request. So we are simply proxying the request to the weather API and returning that back in here. When the application is launched, it's by default going to hit this controller endpoint. However, it will fail because the city name does not exist by default. So let's add that. To do that, open up the Explorer and go to the properties and launch settings.json. Inside here, we can see multiple profiles. Here I'm using the making HTTP request profile to run this. You can also click this and choose the other profile which is using the IIS Express. Let's pass in the city name to this launch URL using the question mark and specifying city name is equal to, and in this case I'll give Brisbane by default. So if you want this to happen for IIS Express, you'll have to add it for the launch URL above here. So let's save this and run this application to see what happens. So it hits the default URL, passes in the city name in here, which we just specified in the launch profile, which is now making a request to the weather API and returning us back the JSON data, which is what we saw in the API Explorer as well. Now this is all working fine. So if I was to change the city name and make a request to London, this is now going to return the data for London. From the outside, the application is now working perfectly fine. However, let's take a look at the network statistics to look what's happening behind. To do that, I will open the command prompt back again and use the command netstat. If you're new to netstat, it displays active TCP connections, ports, and other statistics that's related with the network. Let's use this, specifying some of the parameters from here to see how the network statistics is for the requests that we are making to the weather API. So let's open up the console and specify netstat and specify some parameters A, N, and O. You can check what these means in the parameters table in here. The link to netstat is there in the description below. So let's go back and make this request. You can see there's heaps of data that's coming from the netstat call. Now we need to filter this so that we can see exactly what we want and the request that's getting made to the weather API. So let's go back to the source code and copy the API URL. So under the weather forecast controller, we have api.weatherapi.com. So let's copy this, go back to the console. Let's make a ping request to this API host to see what the IP address of it is. So let's use that. And this specifies the IP address is 185.90.83.2. Let's copy that and make the netstat request again and pass the parameters A, N, and O. But this time, let's also filter this output using the find str function. So in this case, we want to filter it by this IP address. And we see that there's no request right now. So let's go back to our application and refresh this call to the weather API. So since this request is again made, let's go back to the command line and make a request again. Now you can see that there is a record for this particular API. This is because we made a request to this particular API to get the data from our ASP.NET Web API. Let's go back again and make another request to see what's happening. Let's come back to the client again and rerun the netstat. As you can see, this time we have two more records. You can see that there is two ports that's getting opened up here, which is on this particular application. Every time we are making an API call, it's creating an underlying socket and opening up a new connection to the weather API. Now this is not something that we want. Also note that these connections are still in the established and open condition even though we are done with our request. Let's go back to the code and see what's happening. Now in here, we can see that we have simply used the HTTP client but not disposed this client. You can either explicitly dispose this HTTP client or wrap this whole call inside a using statement. So let's do that for now. So wrap the whole calls inside a using and make sure we have the braces around that as well. Let's run this application again to see if anything has changed. We have made the first request. So if we were to go back to the console and run netstat again, we can see we have one request. However, note that this is now time_wait, which means it's not in an open condition. Let's make another request for London and also make another request for Texas. So we have made 3 requests in total. So let's go to the console and run the netstat again. This time, you see that there's 3 requests. However, the connection status is now time wait. The time wait status indicates that we have closed the connection from our side, but we have still the connection open to see if there are any packets that's delayed over the network. Now if we were to run this again, this is going to get disposed of after a default timeout period. But for every request that we are making, HttpClient is creating an underlying socket. So in this case, we are going to soon run out of sockets if we have a lot of requests. This is usually referred to as the socket exhaustion problem. So once you reach the limit of the number of sockets that you can create on the system that the application is running in, you will not be able to create any more instances of HttpClient. So let's see how we can solve that. In the weather forecast controller, instead of creating a new HttpClient every time we create a request, let's make this a singleton instance. To do that, let's add a private static property into this class. So let's call this private static HttpClient and specify the name as _HttpClient. There are different ways of making this property a singleton and making sure it's only getting created once. To set the value for this instance, let's create a new static constructor for the weather forecast controller. So let's specify static weather forecast controller and create the _HttpClient instance inside that using the new HttpClient. Let's come down and make sure we use the new HttpClient instance that's part of the static variable. So let's remove the using statements and also make sure to replace this using the _HttpClient. Now in this case, the HttpClient instance is only created once when the application starts, and then it will be reusing that static instance from this class variable. Let's run this to see how this is working. It has made a request to the API and got back to the response. Let's go back to the console and run the netstat again. This time we have a single connection, but note that this is still in the established connection state. Let's refresh this request and make a couple more. So let's make a request for London and also refresh that. Let's come back to the console, clear this and run the netstat command again. Note, we still have only one connection opened up to the API and it's still in the established connection. This is because we are using a singleton instance which opens up the connection and maintains that throughout the application's lifetime. So depending on any number of requests that we make from here, so if I was to refresh it any number of times and come back to the netstat and run this, it's always going to show 1. Now from the outside, it might seem that this has fixed all our issues. However, note that we have an open connection to the weather API endpoint. In any case, if there are DNS changes or other network related changes that can affect the connection, this application is then going to fail. We'll have to restart the application so that it will create a new instance of the HTTP client. This is not something that we want. So let's see how we can fix this. To cater for these different issues related with HTTP client, .NET Framework has built-in support to create HTTP client instances. This is using the IHttpClientFactory. Let's go back to the controller. Let's remove the private variable and the singleton instance from here. And instead of using a new HTTP client, let's inject in an IHttpClientFactory into this constructor. So we can use IHttpClientFactory and specify HttpClientFactory. Let's create a read-only field in this class. In the get method, let's create a new HTTP client instance using the HttpClientFactory that we just injected in and calling the create client method. This is going to create a HTTP client instance for us. Let's use that to make the call to the API. To register the IHttpClientFactory under the startup.cs class, under the configure services method, we need to call in the services.addHttpClient method. This is going to register an instance of the IHttpClientFactory for this application. Now that this is set up, let's run this to see if this is working as expected. The application is making a call to the API. We can also change the cities to get this to hit different cities. Let's go back to the console and run the netstat command again. Note that here we only have one instance and connection maintained to the API currently. So let's refresh this to make sure we are hitting the application multiple times and come back to the netstat and run that again. So we still have only one connection and it is still in the established state. By using the HttpClientFactory.createClient method, we are reusing the connections to the external API services. So let's look at what the IHttpClientFactory is giving us. In the documentation URL, it has specified all these issues that we have seen with the HTTP client and what the benefits of the IHttpClientFactory is. So this provides a central location for naming and configuring logical HTTP client objects. We will see that in a second. It also helps us to avoid issues and problems that can occur when maintaining and managing HTTP client lifetimes, and also the DNS related issues that we saw before. There are multiple ways of consuming the HttpClientFactory. What we just saw is the basic usage where we simply call the HttpClientFactory and call the createClient method on that. We can also create named clients as part of the HTTP client registration in the startup.cs. Using named clients are a great choice when the app requires many distinct uses of HTTP client. So imagine you are calling multiple API services in your application. In this case, using a named client is going to be more helpful. So when using a named client, we can set up some of the common properties for the HTTP client instance right up front. In this example, let's see if we can extract this out as a base URL for the HTTP client using the named client method. Let's remove this base URL from here and go back to the startup.cs method in the place where we are adding the HTTP client. Let's use a name for the client. In this case, we'll name it weather. Let's configure the HTTP client instance defined here. Let's specify an action delegate which is going to take the HTTP client instance. In this case, we can specify the base address to be a new URI and pass in the value that we just copied. So this is going to set the base URI for this client whenever it's resolved using this name. To start using this in our application, let's go back to the controller, and instead of simply calling the create client, let's pass in the name weather. So this is by default going to resolve the instance that's created by this registration here. This is also going to have the base URL set automatically. Let's try and run this to see if this is working as expected. The application is running and it has successfully made a request to the API. Let's also make a call to London and we get back the data as expected. Let's go to netstat and see the request, and this is also as expected from before. When using name clients, you can also configure the HTTP client to specify default headers or anything else that's common to all requests made to that API. The next consumption pattern that we will see is called typed client. In the name client, we were using string names such as weather to refer to the client instances. Now this is something that works. However, in case you want to remove that, you can use a typed client. So typed client provides capabilities without the need to use strings as keys, and it also provides other benefits as listed here. So let's see how we can refactor our code to use a typed client. So let's go back, stop this application, and add in a weather service class. So let's open up the Solution Explorer and add a new class which is called the weather service. So this service is going to help us to make calls to the external weather API. I have the code already written out, so let me copy paste that inside here. We have an iWeather service interface which has one method to get by the city name. So this is implemented using the weather service class, which is using an HTTP client as before. So this makes a request to the API using the API key, and the base URL is again registered elsewhere. So going back into the weather forecast controller, instead of taking in an IHttpClientFactory, let's now take in an iWeather service and call this weather service. Let's make sure to create a read-only field to store this and remove the IHttpClientFactory, which we no longer require. So let's remove that. Let's clean up this code and make a call to the weather service and return using the get method. So we can pass in the city name and return this and add in an await. To register the iWeather service, let's go to the startup.cs, and in the add HTTP client, let's remove this named registration and specify a typed registration. To do that, let's specify the iWeather service interface and also specify which class is implementing that particular service. In this case, weather service. The rest is as before. So we are overriding the base address to be this URL. So let's run this application to see if it's working as expected. Let's make a request to London and it returns us the data from London. Let's go back to the netstat and make sure that we only have one connection and that's still in the established state. No longer are we depending on string names to resolve the HTTP client. The weather service is taking in an HTTP client instance which is directly getting injected because of this startup registration call. So if you are talking to multiple APIs, you can create multiple add HTTP client calls and specify those services in here. Whenever we are using the IHttpClientFactory, it is an HTTP message handler which is getting reused. So this message handler class is what is responsible for creating the socket connections. So here you can see we have the controller which is getting injected in a service. In our case, this was the iWeather service, which also takes in an IHttpClientFactory. Since we registered it using the type client, we didn't have to explicitly pass in a factory, but the dependency registration service took care of this for us. The HTTP message handler instances is getting reused across the multiple calls that we make to this particular service. This is why we only see one socket getting opened for this application throughout its lifetime. The connection pooling makes sure to time out these instances regularly so that the DNS changes wouldn't affect our application. I hope this helps you to understand better on how to use HTTP client instances in your ASP.NET Core applications. We have seen the issues of directly creating an HTTP client instances and how to solve that using the IHttpClientFactory. We have also seen the different consumption patterns that you can use with the HttpClientFactory. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, please make sure to subscribe. Thank you and see you soon.